Stuart Fordyce and Phil Clarke from Novus Consulting. It's about the US and what's been going on there, and Stuart is going to give us a talk. So over to you.
Okay. As part of a background study to a lot of work we've done in shale gas, we've had a look at the US shale basins. The US is quite unique in that there's lots of shale gas production, exploration in the States, which seems to be unique compared to more or less anywhere in the world that there's where there doesn't seem to be any shale production as yet. Move on. It's a bit of as to why shale gas actually matters in the US. Yes, it's technically possible, but apart from being technically possible, why is it desirable? We're not going to cover all of the magnificent 7 famous shale plays today. We're going to concentrate on the Antrim and the Barnett and discuss how and why these work or don't work. Is unconventional actually a relevant term now? 46% of the market it's in the US between the 4 main types of unconventional gas. It's a different form perhaps, and gas is certainly important to the US energy supply. Shale gas, whilst is growing rapidly in production, it is still 10% of the US shale market. People are very excited as to the potential there that is huge, but at the moment what is actually going into the pipelines is quite small. But it's still 2% of the total energy supply in the US, which has resulted in a big change. There's not, in some ways, for some parts of the US gas business. At the start of the century there was LNG terminals being constructed to deal with LNG imports. The predicted figure for this year is 1.8 BCF a day. It's a lot less in capacity, and that fall in LNG imports has largely been due to the shale gas phenomenon, which is some bad news if you own an LNG business. It's almost been, there is essentially, whilst there's a facility to take LNG into the US market, there isn't actually a demand for it particularly. So carrying on, I want to see what we can learn from American shales and then transfer that across to Europe if at all possible. Shale gas isn't new. We've known about shales are well known worldwide as hydrocarbon source rocks in any case. First shales were produced on a local scale to light a pub in the village of Fredonia in 1821. People have produced shales on and off with industrial scale development starting in the 1920s, and it's going on and off with increasing and falling gas prices throughout much of the 20th century. The start of modern shale gas story really begins with the Antrim shale in the mid-1980s, which was pioneered by a tax break in the state of Michigan on unconventional gas sources, which presumably made that more attractive, and by the efforts of, it's obscuring the microphone, sorry. Right, we'll have another go at that. Hopefully everyone can hear me clearly. As soon as I stop fiddling with that. Right, and the Barnett shale has really brought about most of the modern shale gas development. We can see from the historic figure here that the Ohio shale dominates 100 BCF a year, which on the bottom chart from the modern shales is somewhere down here that doesn't even register. Since the 80s and 90s has dominated at the moment in terms of production by the Barnett, thanks largely to the persistence of Mitchell Energy, which we'll maybe one day find out why George Mitchell persisted in the Barnett, given that the flow rates in other shale plays were not what we would consider attractive. There's a staggering statistic here that half the gas produced in the US comes from wells drilled within the last 3.5 years, which has mainly been an expansion in shale gas activity, although anecdotal evidence suggests if you have a more recently produced field, you have priority to get that into a pipeline over an older field. I have to do some more research into that before finding out the final answer though. The increase in shale activity has made shale gas companies attractive, and there's been a recent spate of deals, mergers and acquisitions and trade in US shale plays. Discussion, I've kind of preempted my own slide here. As we can see though, that not the consumption for the US in terms of its gas needs and the domestic supply is predicted actually to narrow rather than to fall apart, which is probably quite different to many other areas of the world. You can see that LNG imports are going down, and shale gas is providing much of the projected growth in gas, along with the other unconventionals such as basin-centred tight gas and coal bed methane. And shale gas is predicted to rise greatly. It's going to go up over almost 5 times. So it's an area where there's a lot of growth predicted in the US at the point in time. And as we can see, most of the reserve additions have actually come from unconventionals, with conventional reserves falling over that time. And if you go back through historic literature, we find that the resource, is maybe the best way of putting it, available for shales has increased greatly. The technically recoverable in the Barnett is at the moment 44 TCF. That may rise. And this gives the Americans a happy situation that with conventional and unconventional gas, we have various estimates of 90 to 116 years worth of supply available. It's definitely a different situation to Europe. What are shale gas? I'm sure there's a lot of geologists and petroleum people in the room here. So shales are source rocks which we've known about for some time. The point here is that a shale is extremely low permeability, even compared to a normal oil field rock. And the gas in place estimates for shales are very large. I think for the Barnett, although we've seen there's 44 TCF estimated recoverable, there's around 260 TCF estimated in place, so recoveries at the moment are quite low. The one aspect of shales which work is that the production requires a high density induced fracture network, which is helpful, which needs natural fractures to be present, but do not necessarily need to be open fractures. I'm not going to dwell too much on the mineralogy of the shales, because whilst it's widely agreed that the ability to fracture a rock is extremely important, what makes for an ideal shale gas rock is at the moment still, there's conflicting information. There does seem to be a general consensus that low clay mineralogy, low amounts of clays are good, and there are fractured shale clays which are both clastic clays or carbonate clays. The definitive answer to that isn't available as yet. So, as map of the US here showing a number of different shale gas plays. There are probably more plays opening up at the moment as we speak. I think there's a couple of plays which people are now investigating in California, as well as a number of plays all located across a huge area of the United States. Well, that's partly the reason for the large reserves which are available. Some of these basins are simply enormous. The Marcellus Shale is something like 300 miles long, which certainly contributes to that. Our report which we're working on and this presentation, much of the historical literature majors on what is known as the Magnificent Seven shales. This map shows, hopefully it's clear at the bottom, the US gas pipeline network. So there's the considerable advantage here that the infrastructure is already available, and certainly in terms of the Marcellus and possibly the Barnett, they're already near large centres of population. It's not like gas in the Alaskan North Slope, which requires to be piped for hundreds of miles, or gas in Siberia that's a long way from the market. So the possibility is you can plug your gas straight in and start making money very quickly. The Antrim Shale was the first, beginning in the mid-80s, the first shale to be commercially developed using more modern technology. The basin is extremely simple, as you can see from the cross-section. It's a large area, although activity now has somewhat tailed off. None of the major US shale gas players such as Devon, Chesapeake, or Encana are currently active in the Antrim. It's not, at the moment, an interesting area. And some of the reasons for that are to do with the geology of it. It's cheap to produce because it's shallow and it has natural fractures, so the requirement to run large-scale frac jobs, which we've seen in previous presentations, is somewhat less. There are, however, problems with the Antrim. It's still, in terms of how the gas generation, is still not massively well understood. There's the general consensus that is biogenic rather than thermogenic gas, and so, although some papers suggest that in areas to the south where Antrim exploration has just begun, may be thermogenic. However, the Vitnite reflectance data suggests much of the core area is currently not in the oil window. The fracturing has been induced here by glacial load rather than by tectonic behaviour. Another problem with the Antrim is that the shales are water wet. A typical Antrim project produces about 30 barrels a day of water, and you can have a CO2 cut essentially at the end of a project to up to 30% CO2, all of which you have to get rid of before you can start making money in the gas. Unlike coal bed methane projects, however, apparently the Antrim has the ability to start production fairly quickly. There's no dewatering lag time, so the water comes out, you can start getting your gas to market quite quickly. This is the problem with the Antrim. Point out the flow rates here. We were only able to analyse 677 wells, and Excel couldn't handle the whole 9,000 wells that we had access to the data for. But as you'll see, the flow rates are mostly in the 0 to 0.2 million standard cubic feet per day, and recoveries of less than 2 BCF per well. We've averaged about 0.69 BCF per well. It's quite a bit lower than what the economics would be for the shale gas projects in Poland that Oswald talked about. So this sort of analogue simply wouldn't work. Moving on. The Barnett Shale really is what has become the archetype for a shale gas play in Texas. The Barnett Shale area the core area is this red area on the map here, which looks quite small but is about 60 miles north to south. So again, a large basin. That's about the distance from St Albans to Brighton, which in the European context has got a number of small sub-basins. So again, a different geological setting. It's again a different setting in that it's a foreland to the Westshire First Front, which is an extension of the Hercynian Carboniferous fold belts, which we know about in Europe. It's a lot deeper than the Antrim Shale, and it's thick. It's a thermogenically produced gas rather than biogenic. There's been about, Vitnite reflectance data suggests that 4,000 feet of sediments have been eroded off the top. It may not be immediately obvious, but there's a small Cretaceous stratigraphy on top of the arch which has been eroded away due to subsequent uplift. Move on from that. The 44 TCF again is what's estimated recovery at this moment in time. That may well increase. So if we're looking for a geological analogue as to where we'll work, the Barnett is deep water. The mineralogy include typically anoxic deep water elements, pyrites and sulfides. The interesting point about the Barnett is it's not actually technically correct to refer to it in the shale in some sense, that it's not fissile, it's actually a mudstone. It can, however, be fractured, which is the key point. The lime mudstone represents the Forestburg limestone, which exists as an independent unit, but is also interbedded in the lower Barnett. As far as I am aware, there is not production from the Forestburg limestone as a reservoir. It's got a mixed carbonate and clastic sedimentology, some of which comes from the carbonates coming from the shelf area here and transported down, and the clastics coming from the Caballos Island Arc. It's been interpreted as the distal end of a number of turbidites, but no Baumer sequence divisions are noted to be present in the Barnett. So that's one interpretation of it. Whether that is borne out, we'll have to see. Move on. Mineralogy, again, can see there's very low clays. It's a granitic rich shale, so it's a characteristic strong gamma ray response. And it's type 2, it's an oil-prone marine kerogen. The core area in the northeast and underneath the city of Fort Worth is where the Barnett is at its most attractive, and that area is often known as the core or tier 1 area, with tier 2 and tier 3 acreage of less attractiveness coming away from that. And the Barnett has a natural fracture network which acts as a plane of weakness during hydrofracking. The fractures themselves are full with diagenetic cements due to brines moving during the oocyte orogeny. So the fractures are not themselves an original storage place for gas, but merely aid the fracturing of the gas, which is an important point when choosing acreage. Near the thrust front itself, the degree of fracturing increases, and that has a negative impact on productivity, as a lot of the fluid can apparently escape up the fractures rather than helping to fracture the Barnett itself. Another issue in choosing to plant your wells is the Ellenberger limestone underneath the Barnett is porous and water wet, and if it's fractured too close to the Ellenberger limestone, you can lose a lot of frac fluid into the underlying formation. So well placement is very important. Now, we've got a chart here. This is not necessarily come out very clearly. That's 8,000 at the top there to 1,000 number of producing wells, which is number of highlights here, which is the beginning in 1997 of water fracturing. Water is still the primary component of frac fluids, but now people also include some ethylene glycol and some acid where appropriate as well, but only in very small amounts relative to the amount of water. And sand acts as a proppant to hold the wellbore open. People in 1998 refractions, the ability to return to the wellbore, perform an intervention, fracture it again and aim to get more gas out, and horizontal drilling comes through as well. I was at a shale gas conference organised by SMI recently in Regent's Park, which some of you may well have attended. I think see a few familiar faces. And one of the speakers from Schlumberger estimated that of the horizontal wells with a number of perforations, which Dave showed earlier, only 25 to 30% of the perforations produced gas. So there's clearly potential for quite a bit of upside if the service companies who design fracturing solutions can manage to place the fractures better and can extract more gas. One thing to be aware of is that, as far as I've discovered in my research, is there isn't a standard for reporting initial production figures. Some are quoted on a 24-hour rate, some are quoted in a 12-hour rate, some are quoted with a choke, some are not. So initial production figures you have for shale gas wells, some of which can be very high, you have to be quite careful with. For the data that Novus has analysed, we have averaged the production over a month to get the first production, which hopefully is a wee bit more accurate. And we would support the estimate that the well returns about 2.5 to 3.5 BCF in the Barnett from a horizontal well. This line at the bottom here, we'll point out, is not a statistical trend. It's an artefact of, again, trying to put too much data into a spreadsheet. And what we can see from this is that there's still quite a lot of wells with low flow rates, less than 1 million standard cubic feet per day, but it shows that selecting the right acreage and then fracturing your well in the right places is quite important, because the economic return versus a 5 million standard cubic feet per day well is going to be quite different. The other thing to point out is most of these wells are still currently active. These are not cumulative production figures in that the well is finished, so these figures will in some cases go up. There's also a number of vertical wells in there which could be they're responsible for some of the lower end figures. The bottom chart shows a random horizontal well in the Barnett Shale operated by Devon Energy. This one's quite a long production time, and you can see this background rate of about 600,000 standard cubic feet per day, but we can see that repeated interventions over time have a positive impact on the flow rate and the ability to extract more gas, which is quite encouraging for making money in the longer term, because shale gas wells tend to plateau off if left to their own devices. The background rate seems to fall to a rule of thumb to about 1/4 of the initial production rate. Unlike a conventional well, the plateau is down here rather than the conventional scheme puts up there. Something to bear in mind. The characteristics, much larger scale basins. We've looked at the geology of the Magnificent Seven basins, and of those, four of the most successful ones are in a foreland basin. Reasonably simple geological activity, and we've seen there's high levels of activity. There's 7,000 wells drilled in the Barnett, 9,000 wells drilled in the Antrim Shale. These are known petroleum provinces where the infrastructure exists to support that. There's the rigs, there's the service crews. And the technology has had an impact. In the year 2000, only 6% of onshore rigs in the US were actually capable of drilling a horizontal well. In 2008, that figure was 23%. There's still some upside for the rig industry to come, and also, as alluded previously, the ability to produce more gas in fact has to come up. As we've seen, we're talking about well rates going from 200 standard cubic feet per day to 200,000 per day to 2 million or higher indeed. And I take no responsibility for the pun at the top there. It's entirely Phil's, showing parts of the Marcellus, Fayetteville, Woodford and Barnett are part of the Magnificent Seven and are foreland basins. The New Albany is also traditionally known as part of the Magnificent Seven that people used to talk about. Like the Antrim, it is not a foreland basin, it's a failed rift. It has consequently much lower flow rates like the Antrim. A lot of water production. Again, it's not an area where anything exciting is going on at the moment. The Haynesville is another oddity. It's in a salt basin rather than a foreland basin. It's very deep. It's the deepest of the shales, and a typical well cost in the Barnett is about 2.5 million for the horizontal, as opposed to 7.5 million in the Haynesville Dave quoted earlier. And reading an article yesterday, the base case for break even in the Haynesville is about $7 per MCF, so it's probably shut in at the moment. The upside to that is though that the Haynesville can post 15 million per day well rates. It's not untypical from, we've seen others doing 20 or 30 in the data we've analysed. I can cover some of these statistics already, but the technology is really what has driven this. Without horizontal wells, and particularly without the multi-stage fracking, the shale gas industry simply wouldn't be able to flow wells at economic rates. I'd say there's clearly potential for some upside here, even although the cost for the horizontal is much bigger. And it's a standard schematic of a flat horizontal well with multiple stages. This is the scale of a frac job. This alludes to the point Oswald made. There's, we reckon, about 20 trucks, all big American trucks, 48 million gallons of water, and a huge area. This is fine if you're in Texas where everyone works in the oil industry and people are prepared to put up with that. In the Marcellus, which is a beautiful mountain area, there are access issues simply getting this lot in. There are issues with, do people want their beautiful countryside looking like this, even with restorative measures which companies are required to put in place. And this will be a problem in Poland, possibly, but in the rest of Europe you couldn't really do this at which farm was the point someone made. Even although so that's something which we will have to consider. And the wellhead itself is only a very small area in comparison to all of the rest of the infrastructure. And there's also the case that simply getting the crews in the US, that you can do some crews will do 2 to 3 jobs a day. In Europe, a frac crew might do 2 to 3 jobs a week. And there's plenty of business in the US for frac crews. The companies will possibly struggle to get experienced shale gas crews over to Europe to come and work here, so there might well be a skill shortage for some time. Moving on to the deals that have been done. Mitchell Energy was the first deal. They were very much the first movers in the Barnett Shale. And this is all based on public data. The smaller companies are now very much get involved in mergers or acquisitions, or being swallowed up by medium players, who in turn are tying in with multinational companies seeking to gain access to their technology, their understanding of shale plays. And the prices paid are quite interesting. By the time of the Mitchell Devon deal, the Barnett Shale was on production, possibly and paid for the gas that's in production, whereas the Marcellus Shale is a difficult one really to value in some ways. But in the state of Pennsylvania, where much of the Marcellus is located, there's a 5-year moratorium between a well coming onto production and the data being released into the public domain. As we saw with the rig count 5 years ago, it was extremely unlikely that a well drilled would have been a horizontal well with a multi-stage frac, so it's not necessarily informative as to what would happen today. You can see here what people are paying for shale gas, and we'll possibly start to see a similar story in Europe with numbers of smaller companies such as Three Legs Resources or Shootback possibly being taken over by, or forming Three Legs Resources is going into partnership with ConocoPhillips and its acreage in Poland, and we may well see a similar story in other plays around Europe. Moving on, shale gas, we've known about the potential for gas from shales for some time, but it's only recently that technology has enabled us to actually extract this at the gas prices we see today. There is an economic window for shale gas. Too low a gas price, and the ability for shale to be economic decreases. There's too much shale gas, possibly then because a glut of gas in the market and the gas price will fall, and we have to shut ourselves in. The US shale basins may not be analogous to Europe or to the rest of the world. They're largely simple. The scale of them is enormous compared to Europe, and that's why there's enormous resources attached to them. Despite this, there's still questionable commerciality. A presentation I had at another conference based on analysis of Barnett Shale wells suggested that the P50 well for the Barnett didn't actually make money. So it's clearly getting the right acreage and then actually putting it into production at an appropriate gas price is key, because at the moment with low gas prices, probably a lot of wells which are struggling to break even. The other point is that in the US is a common term to refer to shale as a continuous resource, and that throughout the shale the TOC values will be more or less constant, and this really isn't the case that we've to be wary of in Europe, which is a normal play. There'll also be a sweet spot available, which is key to get into. And some of the learnings we can definitely apply across, which requires a step change in European infrastructure. We need a lot more rigs and a lot more service crews in order to make it worthwhile. But I think the story from the US shows that it is possible under the right conditions. So, I think that's us covered most things. I'm possibly just about there for time, if that's 11:30. So if anyone has any questions that based on what I've talked about so far, and that may have finally show that Novas is working on a report where we will be able to show in greater detail the work that we've done on the Magnificent Seven, and also to apply our learnings to basins around Europe. As you can see that, yeah.
Just go back one slide.
Sure.
Okay. Well, first of all, Stuart, thank you. And as you say, bang on time. Any questions? And if not, I will do what I normally do by asking a difficult one. I think there's a gentleman who writes for World Oil in the States called Art Berman, who would say that your despite this, commercial viability remains patchy is a grand overstatement. And in fact, he's done lots of analysis on the Haynesville and other shale gas plays, and he can't see how anybody makes any money out of them at all, never mind at the P50 level. Have you guys come across this stuff? And is it sort of broadly inaccurate or broadly true, do you think? Or close, or what do you think?
In terms of being commercially viable, I think we worked out for the Barnett we needed a gas price, rule of thumb, a gas price is maybe about $5 per MCF. And last year the gas price was hovered around that area in parts of the US, but the Barnett is well known, and as we've seen, wells in the Barnett cost a lot less possibly than wells in the Haynesville, wells in other areas which are more remote, such as the Marcellus, from an established oil industry infrastructure. So patchy is possibly a generous view as to whether it's viable. I wouldn't disagree necessarily with what's been said.
Just add one point to what Stuart said there. If you look at the one of the early slides that we showed, that showed the US production, you'll see that up to the last couple of years, it really has been dominated by the Barnett, and the Acidic could almost say, well, this is actually still a single play industry. We've achieved a step change from what was being done in the Ohio and the Antrim in earlier decades, but the story of the first decade of the 21st century is actually about the Barnett. Well, whether the Haynesville has an opportunity to take over from there and take us into the new decade at a different level, I think is still to be established. Certainly what technology has achieved is to open up the possibility for vastly superior flow rates through multi-stage fracking and through horizontal drilling. But the extent to which that can be applied in many basins, or let's say the majority of basins, I think is still very much an issue to be decided. We may just be dealing with a few rather unique basins rather than general observations that are able to be applied, well, US-wide or on a global basis.
Thank you. Just on the Barnett, and you talked about the different tiers, tier 1, tier 2, tier 3. Could you maybe say how the data changes as you come out of tier 1, tier 2, tier 3? The key data points we like to look at, the organic content, the silica content, the flow rates. Just give us a sense of how that changes across each of the tiers in the Barnett. Thank you.
I'll just zoom to the map in that case. The Barnett gets deeper towards the east and towards the north. It's at its most gas prone, and there's most gas content per area of rock in the north and east here, highest concentrations of organic matter. And the recoveries from there can be will decrease as you go out. In the grade A acreage, you'll get an initial production rate of 2 and above, if you're fortunate, million standard cubic feet, recoveries of 3 to 4 BCF. Going down, once we get out to the outside tier acreage, the initial production could be down at 500,000 cubic feet per day, and from the top of my head, maybe 1 to 1.5 BCF. So there's quite a difference. There's in terms of the silica content in mineralogy, I can't really know. So.
Okay, we have another question up here. Yeah, he's got the microphone.
A very interesting talk. Could you tell us something about the degree to which these gas sales contracts resemble, if at all, the conventional sort of normal gas contracts characterized by enormously long forward-looking terms?
The honest answer is no, I can't. It's still very a work in progress, and that's not something I've looked into. The production profile is quite different to a conventional gas reservoir in terms of the spikes in demand and spikes in supply and a lower background rate. I can't answer that at the moment. That's something to look into. So.
Sorry, just to follow up.
Sure.
On the discussion earlier about whether or not people can make money.
Yeah, I'm away from that. I'm still looking into that.
I'll take you off the hook.
Thank you.
Can you give us an indication of how much, if at all, the interpretation of seismic data directs the thrust of drilling activity?
Much of the drilling in the Barnett tends to be on a grid basis. The shale is known subsurface, presumably both from mapping and from outcrop. I have seen papers which suggest the sweet spots can be targeted by seismic amplitude anomalies. And that may be possible. I'm not an expert on it. Still something for me to look into this. But certainly in the terms of the shales, they're often interbedded, as we've seen mineralogically. So whether some of the organic rich layers could actually are thick enough to be picked out in the seismic resolution might well vary from basin to basin.
Peter, just to help out a bit, as I inferred, one of the slides I used at the beginning was borrowed piece by piece off the BP website. And there is a short, it's 2 or 3 pages, 4 or 5 pages in there, an account of saying this is how we chase down sweet spots, not only in tight sandstones but in shales. And it's based on their US experience. And I'm sure is sort of the result of other papers that they've given, at the SEG and so on. So there's a story at least in that place. Yeah, over there. As it's a long way round, I need to.
Thank you very much. It was a very good presentation. I've got, in terms of the work program, time commitment by the operators in the US to drill these wells on a block, what kind of a time frame are we looking at from the time that you pick up these blocks from negotiated with the farmer or landowner, etc., to actually drilling wells and giving back the block?
Phil, okay.
Reference was made earlier to the fact that a land acquisition in principle was a lot easier in the US than it is perhaps in areas like Poland or intense agricultural areas or built-up areas elsewhere in Europe. In fact, that's not completely true. Land acquisition can actually become the major activity. And I've certainly worked with companies where they have spent years to try to build up the acreage holdings required to be able to exploit these relatively diffuse resources, if you like. So it's hard to give absolute guidelines to this. I think in some of the simpler, less developed areas it can be relatively quick, but I know that certainly does not apply in all areas. and the timescale to land acquisition can be years prior to drilling. The other important point to make, and it goes back to the question that was put into the room a little bit earlier about making money out of all of this, is of course you've got a very different drilling profile once you have the acreage, and once the resource is demonstrated, then you've got far more of a continuous drilling profile to maintain the field production rate than you would in say a conventional oil or gas situation.
Okay, one more question and then we need to move on. So please, over there.
Of late there has been a controversy regarding the shale gas in the United States, and that is related to the fracking process, which causes or potentially causes damage to the water aquifers and maybe also poisoning of the water resources. So do you see that this can be a potential deal breaker or potential problem in the development of shale gas? Especially when you see that a few months back Chevron said that they are not into the shale gas.
There is certainly a public concern about frac fluids ending up in the water table. In the US, largely the shales are considerably deeper than the water table, and my experience speaking to people is that frac fluid is largely recovered from the wellbore rather than seeps into the surrounding formation. A quote from a shale gas company head who I spoke to recently said that we hadn't lost 1 barrel of frac fluid. There is, however, you're right, concern about...
So you...
that was his claim. I'm not passing comment on the accuracy of it, I'm not, but certainly it's in the company's interest to try and recover as much of this fluid as possible. If they're shipping in 4 million gallons of water, that's got to cost them money. They really want to recover as much as that as possible, potentially so it could be used elsewhere. How well the water flows upwards into the water table has not been an issue in the US, but it is a concern.
Okay.
There's possibly a difference between public perception and geological science there.
Yeah. Okay, thank you, Stuart. Thanks very much. Let's move on.